Hey everybody, this is Mr. Woodward. So here I am in the Pivot Interactive's video environment, and we've got this setup here, um, which is a scientific model representing some object that's experiencing circular motion, and we want to measure the centripetal force on that object, right? The force that's pulling the object into a circle. So here's the general video. Got a mass sitting on a turntable. And we want to know what happens when we make three kinds of changes. Okay, the first kind of change would be a change to the amount of mass connected, and right now there's 20 grams sitting on the turntable. The second kind of change is a change to the speed at which the mass is rotating in a circle. And the third kind of change is the change to the radius of the circular path. So if I play this again, this right here is the radius. Okay. All right. So let's think about the first experiment, which is only changing the mass. Okay. So I'm going to call that my independent variable, which means it's the variable that I am changing in the experiment, leaving all other variables constant. All right. So I'm going to start with 20 grams. And I'm going to start with some speed. Now, if I use this, I'm assuming these are going in faster and faster speeds. If I use this speed, I'm now losing some options on radius. I guess not that really matters. I'm going to go with speed 3 and radius d. I'm going to hold those constant while only changing the mass. Okay. All right, so I'm going to load this. And if I hit play, you can see the video. And then I'm going to measure the force that's pulling inward on this mass, right? And that force is showing up on the spring scale because it's connected by a pulley to this string. So it's measuring the tension. All right, this is measuring in units of newtons, 0.2, 0.4, 0.6, 0.8 newtons, all the way up to 1 newton. And so that means that this line right here would be the 0.1 newton mark. And each of these smaller lines must be 0.02 newtons, okay? Because this would be 0, 0.02, 0.04, 0.06, 0.08, and then that would be 0.1 newtons. So this is right at 0.06 newtons. So that is the centripetal force when there's 20 grams. All right, so down here I get to record my data. So I'm changing mass and I'm measuring centripetal force. Right? The units of mass are grams. The units of force are newtons. And I'm going to call this my, this is going to be on my x-axis. This is going to be on my y-axis. So at 20 grams, I got 0.06 newtons of force. All right? What happens if I go to more mass? Let's go to 50 grams. Again, only changing this, not changing the speed or the radius. Loading the new video. And then playing it. So now I've got a little bit more mass, and now my force is higher. It's now at, well, this is 0.1. This was 0.1 here, so this is 0.12, 0.14, 0.16, 0.18, 0.2. So that's right between 0.14 and 0.16. I'm going to call that 0.15. And this is at 50 grams, okay? What if I go to the next mass, 100 grams, and then I'll go to 200, okay? So I'm gonna go to 100, then 200 grams. Okay, 100 grams. Wow, that looks like it's right between 0.2 and 0.4, so that's right on the 0.3 line, 0.3 newtons. And then what about 200 grams? Notice the mass is much bigger now, right? That's a 200 gram mass. Gosh, that's right at 0.6 newtons. Okay, so notice this. If I double the mass from 50 to 100, I exactly double the force. And if I do it again, doubling from 100 to 200, I exactly doubled the force. Man, that sounds like a directly proportional relationship. So I'm going to graph these 4 data points. Okay, I need to configure my horizontal axis and tell it that on the horizontal I want mass. You can ignore this uncertainty column. And notice it plugs in mass with the units. And then on my y-axis, I want centripetal force. And it includes the units. And now here are my points, right? 1, 2, 3, 4. And I'm going to apply a curve fit. And I want a linear fit. Okay, that's a straight line fit because it looks pretty straight to me. And yep, there it is. They all fall perfectly on this line. Okay, so then I actually have the equation of that line in the form y equals ax plus b, where a, which is the slope, is 0.003 newtons per gram. Y, of course, is the centripetal force, and x is the mass. Okay, the b value is the y-intercept, which it's saying is 0. So that means that this intercepts the y-axis at 0 newtons, and that's because if there's no mass, there would be no force. So what you'd want to do is screenshot this, and then since there isn't another window for another graph, you're then going to make a new graph. So you can either go through and like delete all of this and then move on to the next experiment, which would be to now keep the mass constant, maybe keeping the mass constant at like 50 grams or something, changing your independent variable now to speed. So let's say maybe at 50 grams, and now going through the speeds, and then keeping your radius constant, maybe sticking with radius d, but now making only changes to speed. Okay, so then I could load the next video, and it's actually not allowing me to load because it looks like 50 grams is not available for that. Oh, it's because I didn't choose my speed. That's why. Load the next video and then start going back through and collecting new measurements. So you can then change this to speed, or if you don't want to lose that data, you can actually just add a new column, call it speed, and then add a new column to the right of that and call this centripetal force, maybe like number 2, meaning for the second experiment, where this would be number 1. So you don't get those confused. So then you'd fill out your speed column, you'd fill out your centripetal force column, and then on your next graph, you would graph these two, speed and centripetal force. So this graph will now be speed, and I mean this axis, and then this axis would be centripetal force number 2, okay? And then you'll get data points for that. Or if you don't want to create these new columns, you can just go and delete both of these and reuse them. All right, and then when you get your second graph, you'll screenshot that, and then you'll do the third experiment, and then you'll have all 3 sets of data and graphs.